All right, everyone. A couple of you have requested that I do a quick video about gas laws since we're getting into chapter 14 and that time of year to talk about all the different gas laws. So just a quick introduction to both gas laws. You have two that you need to really work with. One is the combined, and the other is the ideal gas law. The combined gas law combines Boyle's law, Charles' law, and Gay-Lussac's law into one. And the ideal gas law, PV equals nRT, is as follows. So, what is the big difference between these two laws? Well, obviously, a lot of people will see right off the bat. The ideal gas law talks about N, which is the number of moles, and also has an R in it, which is our gas constant. That's obvious from just looking at it. But really, in your brain, what you need to realize is the big difference between these two is change. You can see that in the combined gas law, we have initial pressures, volumes, and temperatures, and secondary pressures, volumes, and temperatures. In the ideal gas law, we have no change. So, in your brain, the one thing you're going to have to, when you're reading a problem, is you're going to have to figure out which gas law am I going to use, and you're going to have to see, is there a change in this type of program or problem? Do we have an initial pressure and then we change to a different pressure? Do I have an initial volume and they change to a different volume? Temperature, do I change to a different temperature? The best thing about memorizing the combined gas law the way that it is that you don't really have to memorize your individual gas laws, like Boyle's law, Gay-Lussac's law, and Charles' law. If they ever say temperature is held constant, well, then you just literally get rid of temperature and you're left with the gas law that you need. If they say volume is held constant, well, you erase volume and you're left with the gas law that you need. All right? So that's kind of the way that works out. Now, to get into some more details about these gas laws, I'm going to actually be addressing some problems in Skill Practice 35 that I handed out to you guys. So, we're not going to deal with the ideal gas law in Skill Practice 35. Instead, this is majority, I believe this entire one is all about the combined gas law. So, I'm going to just pick randomly here. I'll do number 2. From Skill Practice 35. Number 2 says a gas has an initial volume of, there we go, they told us initial volume. The best thing you guys can do is pull everything out while you're reading it and label your variables. So initial volume is 2.75 liters. At a temperature, that's also an initial temperature of 285 Kelvin. If the temperature changes, we have a temperature change, that's T2, to 380 degrees Kelvin. What is the new volume? Notice, for this, we're not talking about pressure. So we had P1 V1 T1 equals P2 V2 T2. And like I instructed you before, just get rid of pressure. So ultimately, I don't like that. So ultimately, we're left with this, and what they want us to solve for is V2. The best thing that you can do before popping numbers in and then manipulating is to isolate your variable first. So I want to solve for T2. For V2. In order to solve for V2, I can multiply this side by T2 over 1. That's going to cancel out T2. Whatever I do to that side of the equation, I have to do to this side of the equation. So therefore, I get T2 times V1 over T1 equals V2. Again, T2 times V1 over T1 equals V2. Now I can go ahead and pop my numbers in. Well, T2, 380 Kelvin, times V1, that's messy, 2.75 liters, divided by T1, 285 degrees Kelvin. Now the best thing about this is look at the units that cancel out. Kelvin cancels out with Kelvin, leaving us with liters, which is a unit of volume. And if I just pop that into my calculator, 380 times 2.75 divided by 285, I get an answer of 3.66666667. So that all comes out to 3.67 liters, and that is what V2 equals. So that's how I did that one. All right, let's do another one. Let's do number, let's just go ahead and go for 4. Again, I'm just doing random stuff here. So the volume of gas is 2.5 liters, volume. I don't know if it's initial volume or not. I'm just gonna label volume, 2.5 liters. When the pressure is at standard pressure, so pressure is 101.325 kPa. What is the volume of gas if the pressure decreases? So now we have a decrease in pressure. That means this was initial pressure. So P2, the volume just decreased, or the pressure just decreased to 85 kilopascals. That makes, we have a change here, change in pressure. Well, that pressure was related to that volume, so that means that's V1. So it says, what's the volume of gas? Again, we're solving for V2. I'm not going to do too much more of this problem because it's the same problem that we really just did, solve for V2. So we have P1 V1 equals P2 V2, because I got rid of my temperatures. Doesn't say anything about temperature in this problem, so I just got it out of there. So I divide this side by P2, divide this side by P2, and I get P1 V1 over P2 equals V2. So again, 101.325 kPa times V1, 2.5 liters, divided by 85 kilopascals. Notice that kilopascals both cancel out. 101.325 times 2.5 divided by 85, and I get V2 equaling 2.98 liters. That's the only unit I'm left with. All right, so that's that one. Let's go further down. Let's do something like number 8. Number 8. Isothermal expansion refers to allowing a gas to expand while keeping the temperature constant. They just told us temperature is constant, so we're not going to worry about T1 and T2. This is one means to simulate a vacuum. If a gas originally at 97 kPa, that's going to be a pressure measurement, so that's P1, is allowed to expand from 0.25 liters, it's going to be V1, to V2, 182 liters. What is the pressure of the gas? That's what they're asking us for all of it. All right? So we're going to solve for P2. Our equation, P1, V1, P2 times V2. They're asking us to solve for P2. So I'm going to divide this side by V2, divide this side by V2. That gives me P1 V1 over V2 equals P2. Now I just go ahead and pop in my equation. 97 kPa times V1, which was 0.25 liters, divided by V2, 182 liters. And so 97 times 0.25 divided by 182. And I get P2 equaling 0.133241758. I'm just going to go ahead and round this to 2 decimal places. So I'm going to say, since my liters canceled out, that's 0.13 kPa. Final answer. All right, so you can see that the steps here, most important steps in establishing gas laws. First step, figure out which gas law you're going to use. Are you going to use the combined, or are you going to use ideal? This is change. This is no change. All right. The next step is to write down and label variables while you're reading this. The third step, before you put any numbers in, isolate the variable you need to solve for. Then you pop all your numbers in, all right? And that's pretty much how to do Skill Practice 35 and a real quick tutorial on gas laws in general. Good luck, everyone.